Let's solve more examples. I will solve another example which is similar to the previous one. 1 over n plus 2 times n plus 3. Okay, let's try it to find out if it is convergent. If it is convergent, what is the sum? When you have such an expression, okay, partial fraction is best technique to use. That's why I'm gonna go with this one. There's no other technique actually. That's the only technique, and then that's the best technique you can use. You see, I have two fractions here, right? And then for each fraction, look at that, I can have one of these terms. And what I'm gonna do, I'm gonna make the denominator equal. I'm multiplying by the missing terms, you see? After multiplying, I will have the same denominator. I can cancel them out. On the left-hand side, I'm going to have 1. On the right-hand side, I'm going to have a times n plus 3 plus b times n plus 2. So if I distribute to right-hand side, a plus b times n, and then plus 3a plus 2b. A plus b is going to be equal 0. 3a plus 2b is going to be equal 1. And then I know how to solve this linear system, right? From the first equation, a is going to be equal negative b. If I use this one in the second equation, negative 3b plus 2b, which is equal 1. So b is going to be equal negative 1. If b is equal negative 1, a is going to be equal 1. Did you see I found these values? Now, instead of using this an, I can use the right-hand side. So my question will turn into this one. 1 over n plus 2 minus 1 over n plus 3. So this one will help me more, right, to find out the partial sum of sequence. As you know, I need to create, some terms to find out the first n term sum. N is equal 1. 1 over 2 minus 1 over 4. 1 over 3 minus 1 over 4. This is my first term. When n is equal to, I'm going to have 1 over 4 minus 1 over 5, and then so on and so forth, guys, right? I can keep doing this one to get more term, and then I'm going to add the first n term. When n is equal n, it is going to be equal 1 over n plus 2 over 1 over n plus 3. So at this step, you need to look for the terms which you can cancel. You see, I can cancel all these terms. So that's the only term I cannot cancel. And then this is the only term I cannot cancel. So Sn will be equal 1 over third minus 1 over n plus 3. Did you see? Now I can take the limit of this sequence. If I take the limit of this sequence of partial sum, as you know, this limit will go right to 0. The result is going to be equal 1 over third. So I can say that my series is convergent, and then its sum is equal to what? 1 over 3. You see the power of math, right? We just calculate the sum of infinite remaining number. Another example. This is going to be interesting since I'm going to put here the ln type of terms. ln n plus 1 minus ln n. So the question is the same. Is it convergent? If this series is convergent, right, what is the sum of this series? So first of all, what I will do, I'm going to try to find out the sum of partial, sequence of partial sum. Sn is equal ln 2 minus ln 1, when n is equal 1, this is my a1, plus ln 2, ln 3 minus ln 2, right? This is my a2, this is n is equal to ln 4 minus ln 3 and ln n plus 1 minus ln n. Okay. In this way, it is really hard to find out the limit of this sequences. Of course, there are some the terms around, I can cancel them out, but still, I'm gonna have this terms, which I might not be able to cancel one of these, okay, in this way. This is why, okay, I will use the ln feature to write in a compact way. You can ask, okay, why didn't we use the partial fraction? This is not the rational term, guys. You cannot use the partial fraction. This is another question. That's why there is no place to use the partial fraction for this question. Instead of, okay, canceling all these terms, I will do this. Sn ln n plus 1 minus ln n can be written in this way. Ln n plus 1 over n. If I use this feature, look at that, I can create my sum of partial sequence in this way. When n is equal 1, ln 2 over 1. When n is equal to ln 3 over 2. When n is equal to 3, ln 4 over 3, and so on and so forth, right? And ln n plus 1 over n. And then as you know, I have this feature as well. Ln a plus ln b is equal ln a times b. If I use this feature, Sn can be written in this way. Ln 2 over 1 times 3 over 2 times 4 over 3 and n plus 1 over n. Look at that. Now I can cancel in this way, which is easier than canceling those sum terms. You see, if I cancel in this way, n will go away, and then this term will be equal just to ln n plus 1. So I know I need to take the limit of this sequence. Limit n goes infinite. Sn is equal limit n plus 1. When n goes infinite, sorry, this is ln. When n goes infinite, of course, this limit will go infinite from the continuous theorem for sequence. As you know, as you see, I use one more time the sequence limit, to find out the convergence or the divergence of my problem. So what I can say now, the series is divergent, guys, since I find the limit is equal infinite.